Hey there, Algebra 2 students. Welcome back to Miss McGuire's classroom. Today we're going to be discussing Unit 7, Lesson 6. We have a brand new topic today. We're going to be talking about a thing called logarithms. Don't forget to put your first and last name, period, and the date in the upper right-hand corner. So our main topic is Intro to Logs. I'm just going to introduce you to logarithms, kind of show you how they work, how we can evaluate logs, what they're for, all that good stuff. Today's objective is I will evaluate log expressions and write them in exponential and log form. Mastery will be demonstrated by scoring at least 80% on the actual practice. All right, so what is a logarithm? So I have the definition of a logarithm here, and the formal definition is a logarithm tells what exponent or power is needed to make a certain number. So logarithms are the inverse or the opposite of an exponentiation. Of an exponentiation. I don't know why that word made me laugh. So what that means is a logarithm is kind of like an algorithm that's used to express an exponent in a certain way. So let me show you some examples because logs don't really make sense till you just jump in and start working with them. So let's talk about 2 to the first power. So 2 to the first power is 2. And 2 to the second is 4, 2 to the third is 8. If I express these exponent or these powers as logs, they're going to look like this. The log base 2 of 2 is equal to 1. The log base 2 of 4 is equal to 2. The log base 2 of 8 is equal to 3. So notice this exponent is what the log is equal to. This exponent of 2 is what the log is equal to. This exponent of 3 is what this log is equal to. So the log base 2 of 8 is equal to 3. So then notice that this base of 2, so remember in a power how like if you have, let's just say, if you have x to the y is your exponent, x is your base. So notice how if 2 is your base, it's also the base of your log. If 2 to the second is your 2 is your base, it's also the base of your log. 2 to the first, so 2 is the base, it's also the base of the log. So 2 to the third equals 8 is the same thing as log base 2 of 8 equals 3. So that exponent is what the log is equal to. The base of the power is the base of the log. And all that good stuff. So let's try it with another kind of easy to deal with power. Let's do 10 to the first, 10 to the second, and 10 to the third. So 10 to the first is 10, 10 to the second is 100, 10 to the third is 1,000. So when I rewrite these as logs, I'm going to take my log base 10 of 10 is equal to 1. The exponent becomes what the log is equal to. So my log base 10 of 100 is equal to 2. And then this log is going to be equal to 3. My log base 10 of 1,000 is equal to 3. So notice when I wrote my log, my base would be 10, but when we have base 10 for logs, you don't actually write the base. So anytime you see a log and there is no base, it is base 10. Base 10 is the base that like our number system is written in, the numbers we deal with on a regular basis. It's what we call the common log. So whenever you have log base 10, you don't actually write the base. So whenever you see like the log of something and the base is not identified, assume it's base 10. I know I just said a lot of stuff. It'll make more sense as we go. So let's talk about this. The exponent was 1. That's what my log of 10 is equal to. My exponent was 2, that's what my log of 100 is equal to. My exponent was 3, that's what my log of 1,000 is equal to. All right, so I just want to, let's do this. So I should say log form. That's funny. That's a silly typo. Log form and exponential form. So our log form is you have the log base b of x equals y. So this is our log form. Log base b of x equals y. And then we have exponential form. So that can get converted into exponential form, which would be the base b, so b to the y is equal to x. B to the y is equal to x. So our log form, and normally if like you were in the classroom with me, I would have you practice saying out loud how to read a log. You need to be able to say this out loud. You'll need to be able to say it next year. So you might want to take a second right now and just say it out loud, even if that feels silly. The log base b of x equals y. So you would read this as the log base b of x equals y. And then of course you should be able to read this one, b to the y equals x. B to the y equals x. So we can go back and forth between log form and exponential form. So let me show you some examples of that. So we have 100 equals 10 squared. So I'm going to rewrite that as 10 squared equals 100. And then notice that our base b, okay, just kidding, you can't see that. 10 squared equals 100, there we go. Our base b to the y, our base is 10. So we're gonna have log base 10. So the log base 10, and that base is a subscript. So like log, the log is like regular size letter, your b is a subscript. So log base 10 of, and then whatever your exponent was equal to, so the power, b to the y was equal to, that's what goes into the log. So we are equal to 100. That 100 is going to go into the log. So the log base 10 of 100 is equal to, and then the log itself is equal to the exponent. So my exponent is 2. So my log base 10 of 100 is equal to 2. But when we have base 10, we don't write base 10. We just say the log of 100 equals 2, and we know that it's base 10 because the base isn't written. All right, let's try one more before I have you do this on your own. So remember, log form is the log base b of, did I do of x equals y? Yeah. Of x equals y. Exponential form is b to the y equals x. All right, so here we have 3 to the 4th equals 81. Our base is 3. So that's going to be the base of our log. Log base 3 of, and then what goes into the log is what the power is equal to. So that's the 81. So the log base 3 of 81 is equal to, and then your exponent 4 is what the log is equal to. So the exponent is what the log is equal to. Log base 3 of 81 is equal to 4. Okay. So why don't you go ahead and give 36 equals 6 squared a try. Go ahead and switch that to log. All right, so you should have gotten log base 6 of 36 is equal to 2. So 6 to the 2nd power is 36. All right, now we're going to do the opposite. We're going to rewrite the log in exponential form. So the log base 2 of 8 is equal to 3. We're going to rewrite this in exponential form. So remember, you had the log base b of x equals y is the same thing as b to the y equals x. So our base of the log is 2. Our base is 2. 2 to the, then whatever the, whatever the log is equal to, that becomes your exponent. So the log is equal to 3. So that's going to become my exponent. So 2 to the third is equal to. Then whatever was inside the log is what the power is equal to. So that 8. So 2 to the third is 8, which makes sense, right? Isn't 2 times 2, which is 4 times 2, 8. 8 is equal to 8. So 2 to the third equals 8. All right, now you try. So log base 4 of 1/16 is equal to -2. Put that into exponential form. So your base stays the same. Your base is 4. So base 4 to the -2 is equal to 1/16, which makes sense because for 4 to the -2, to make that exponent positive, we would move it to the denominator. So we would have 1 over 4 squared, which is 1 over 16. So that makes sense. 4 to the -2 is 1/16. So that's how we go back and forth between log and exponential form. Now let's learn how to evaluate a log or find the value of a log. So log base 8 of 32. If we have the log base 8 of 32, how do I find out what that's equal to? So what is log base 8 of 32 equal to? We're just going to say it's equal to x. So, is that what we had it equal to? No, we had it equal to y. Let's do y. You can have any variable you want. So that means 8 to the what power is equal to 32. So all I did was I set the log equal to y, and then I switched it to exponential form. So 8 to the what power is 32. So I don't know how to do that in my head, but we could try a few things to solve this. One is 8 and 32 can be rewritten as the same power with the same base. So when I have 8 to the y, 8 is really 2 to the third power. 32 is really 2 to the fifth power. So 2 to the third to the y would be 2 to the 3y equals 2 to the fifth. And then we just solve it from there. So check this out. If our bases are the same, then that means that the exponents have to be the same too. And by the same, I mean equal. So these bases are equal. That means the exponents are also equal. So I'm going to rewrite this as 3y is equal to 5. So if 2 to this power has to be equal to 2 to this power, then that stands to reason that these two things would also be equal. So 3 to the y must be equal to 5. Divide both sides by 3. Y would be 5/3. So that means that 8 to the 5/3 should be equal to 32. And if you plug that into your calculator, 8 to the 5/3 will give you 32. So that means that our final answer, we're going to write it as the log base 8 of 32 is equal to 5/3. All right, now let's do example 4. So example 4, I'm going to walk you through this step by step. So the log base 5 of 125 is equal to y. Rewrite it in exponential form. So 5 to the y is equal to 125. You could probably do this in your head. 5 to the what power is 125? Let's see, 5 times 5 is 25. 25 times 5 is 125. So that means that 5 to the y is equal to 125 can be rewritten as 5 to the third. Well, hey, my bases are the same. That means my exponents must be the same as well. So y is simply 3. So that means that the log base 5 of 125 is equal to 3. All right, go ahead and do example 5 on your own. What is the value of log base 2 of 32? All right, so you should have gotten the log base 2 of 32 equals y. So 2 to the y would equal 32. 32 can be rewritten as 2 to the fifth. Since these bases are the same, the powers must be the same, or the exponents must be the same. So that means that y is equal to 5. But that's not actually my final answer. You need to write the log base 2 of 32 is equal to 5. All right. And last but not least, we kind of already talked about this. The common log is log base 10. It's the base that our number system is written in, like I said earlier. So whenever you see like the log of x and there's no base written, that means that you're using base 10. So if you were to look at your calculator, if you have a calculator, hopefully, why can't I open my calculator app? Hang on. There we go. So if I look at my calculator says log of whatever, the log of 100, for example. There's no base written. So what base is my calculator using? My calculator is using log base 10. So that means that the log base 10 of 100 should be 2, because 10 to the second is 100. All right. That's it for today. Make sure you do your extra practice and let me know when you're done. We'll go over it together, and I'll see you guys back in class. Have a good day.